In the last video, what we have seen is selection sort. So in this video, we will be seeing about insertion sort. Again, I am repeating, what is a sort? Sorting is nothing but process of arranging elements in a particular order. Either it can be ascending or descending, or if it is a list of string values, you can arrange them in alphabetical order. So in insertion sort, so I will just revise the previous one, just give a small recap. So bubble sort is comparing the adjacent values and sorting. Selection sort is selecting the minimum element for each iteration. Insertion sort, insertion, insert. You are inserting the minimum element by comparing all the previous values. Just I will explain you, then you will understand the sentence. Now we will take a list of values which is already your book example. I am taking the same example. 8, 7, 13, 1, minus 9 and 4. So in the first outer loop, I am checking, I am comparing only this values. If you compare this values with this value, nothing is there. So I am not printing anything. Next, here also we have two for loops. If there are two for loops, the time complexity, the processing time of that particular program is n square, two for loops. So here we have 6 values. So 6 into 6, 36. 36 is the time complexity. So the first outer loop I equal to 0. Next I equal to 1. In I equal to 1, j equal to 0. So this both we are comparing. If you compare this both, what is the value? 7 is the minimum. So we are pushing this 7 here and we are just swapping both the values. Next, let us see in the next iteration, loop I equal to, this is the outer for loop, I equal to 2. Here what I am doing? I am comparing 13 and 8, not only comparing the adjacent, also comparing the previous value. So 7, 8 and 13. If you compare this both, 8 and 13, it is the same. So it is all, if you compare also, this all smaller than this element. Next one, I equal to 3. Here what I am doing? I am comparing this both. Which one? 13 and 1. So 1 is smaller. So you will put 1 here and 13 here. So it will become 1 and 13. Again what it will do? This 1 will be compared with this one. Again it is smaller. This 8 will be brought here. Again now 1 will be here, 8 will be here. This 1 will be placed here and 7 will be placed here. So this is how this has come. 1, 7, 18, 13. Not only the adjacent elements, it will compare all the previous iterations also. All the previous value it will compare and bring the minimum one. So for the next iteration, you have to take minus 9. If you take minus 9, what will become? This is the minimum value. So this will get compared to all. So minus 9 will be placed here. Then 1, 7, 8, 13. Next iteration, what will come? This 13 is there. Then 4, next iteration you see 4 is here. So 4 will be compared to 13. 13 again it is compared to 8 here. So it will be placed here. 4, 7, 8 and 13. So this is the value for the insertion sort. So just I will repeat this one. Insertion sort, what you are doing, not only comparing the adjacent elements. If you let us take for this pass, okay. For this iteration, it will not only compare with this one, it will also compare with the previous value. So that is the difference of insertion sort and bubble sort. In bubble sort, we are comparing only the adjacent values. But in insertion sort, what we are doing? We are comparing the adjacent value and also the previous value. So all these three will be compared together. Okay. If I come to the fourth iteration, all 4 will be compared. Then this all 5 will be compared and all 6 will be compared. Okay. But in bubble sort, it is not like that. Only this 2 will be compared. Then this 2 will be compared. Separate it will be compared. In selection sort, what you are doing? You are selecting the minimum, placing in the first pass itself. Selecting the next minimum, placing in the second position. Then third, then fourth, then fifth, then sixth. Likewise, in each pass, you will get the correct exact minimum value to the respective position. So this is all about bubble sort, selection sort and insertion sort. Now we will see a small example of insertion sort. Same way, we are having a list objects called num. We are appending all the values 8, 7, 13, 1, minus 9 and 4. We are finding the length. we are having two for loops for I and for j. Here it is from 0 to n. Here it is from 0 to I because we are comparing the adjacent plus the previous one. If suppose I equal to, let us take the second pass 0, 1, 2. Second pass means from 0 to 2. 0, 1 and 2. All the three values are compared. That's why I am giving the j loop range is from 0 to I, not 0 to n. We need to compare all the previous values. That's why it is from this you have to keep in mind 0 to I. Okay. Then if num of j is greater than num of I, num of j is num of 0 is greater than num of 0, you are swapping the values. Same way for I equal to, let us take for I equal to 2. So 2 means 0 to 2. So first num of 0 and num of 2, then 1 and 2, then 2 and 2. Like that it will be compared and it will be swapped. All the elements will be swapped through the insertion sort. So let us run and see this program. Here you can see in the first iteration nothing is interchanged. In the second iteration 7 and 8 are interchanged. Then third iteration this 3 will be compared because there is no need of swapping the values. It is already this 3, if you see, it is in a sorted list. Next the first 4 will be compared. If you compare this 4, this all will be sorted. This is 0 to I, 0 to 0, 1, 2, 3. This is 0 to 3 will be there. So if I equal to 3 means all this 3 will be coming 0, 1, 2, 3. That's why this range is given. You have to understand that one. So we will be comparing all these 4 values and 1 will be placed. So in the next iteration this 5 only will be compared. Okay. So minus 9 will come. Then at the last iteration this 4 will be compared and 4 is placed in the particular position. This is how the insertion sort works. So for all the 3 sorting, the time complexity is n square. N square. Time complexity is n square. Just remember that. Time complexity is nothing but the processing time of the particular sorting. Time complexity of sorting, bubble sort, time complexity of sorting, no, just I'll say time complexity of bubble sort, selection sort and insertion sort all is n square. If you say for this particular program 1, 2, 3, 4, 5, 6, 6 into 6, 6 is the n value, 6 into 6 is 36, 36 is the time complexity. Okay. So we'll see with the next chapter 6 in my next video. So have a nice day. Happy coding. Thank you.